Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
You know those technical manuals? The ones you immediately toss aside? Yeah, we've all done it. Well, today we're going to do the exact opposite. We're going to dive deep into the official rulebook for one single, seemingly simple machine part. And what we're going to find is a whole world of hidden complexity and mind-blowing precision. So let's get into it.
So what are we looking at here? This is a linear motion guide, or LM guide for short. Now, you've probably never actually noticed one of these before, but I can pretty much guarantee they're all around you. Seriously, they're like these invisible workhorses tucked away inside, well, everything. From factory robots to medical scanners. And they have one simple but absolutely vital job: to let things move in a perfectly straight line with basically zero friction.
Okay, but think about it. What does it really take to get that kind of perfection? I mean, to make something move flawlessly, not just once, but millions and millions of times over. You might think the secret is just in the design of the part itself, but you'd only be half right. Turns out, the real secret is hidden in plain sight. It's in the instruction manual. But listen, this is not just some guide you skim through. Oh no, this is more like a high-stakes set of laws. You break one rule, just one, and the precision of the whole system, it's gone. So, yeah, let's uncover these hidden rules. So, first things first, why does this thing even exist? I mean, why do we need something this complicated? Well, it all comes down to a core engineering problem. How do you get something to move in a perfectly straight line with as little friction as possible? Because without that, our machines would be, well, sloppy, inefficient, and just plain inaccurate. And that's where the LM guide comes in. It's the solution. The easiest way to think about it is like a tiny train on a perfectly straight track. See, inside this block, there are these tiny little balls that are constantly recirculating, gliding along a steel rail. It's a really clever design that basically transforms that chunky, high-resistance sliding friction into super, super low rolling friction. And that is the secret sauce to its smooth, precise movement. And right away, we get our first big clue about just how sensitive this thing is. The manual doesn't kick off with, here's how to assemble it. Nope. It starts with a huge list of what you should never do. The very first chapter is just a series of really stark warnings. And honestly, these warnings tell you pretty much everything you need to know. Even though it's made of solid steel, this thing is surprisingly fragile. If you mishandle it, even in ways that seem totally minor, you can cause permanent, invisible damage. Okay, so rule number one, the big one. Do not take it apart. Ever. The block and the rail are made as a perfectly matched set from the factory. The tolerances are just so unbelievably fine that even if you manage to put it back together, it would never ever get back its original precision. They're basically born together and they have to stay together. Next up, rule number two, don't drop it. And this one really drives home the level of precision we're dealing with here. A drop might not even leave a visible scratch on the outside, but the impact can create these microscopic dents on the internal raceway. That's the little path where the ball bearings roll, and just one of those tiny, tiny dents is enough to mess up the smooth motion forever. Game over. And finally, we have the ultimate enemy of precision, dust. The manual is super clear about this. A single metal shaving or even just one speck of dust that gets inside can totally wreck the internal parts. The space between those little rolling balls and the track is so minuscule that any foreign particle is like throwing a rock into the gears of a precision watch. It just grinds everything to a halt. Okay, so if just handling the thing is that tricky, can you imagine what it takes to actually install it? Yeah, this is not like snapping together Legos. It's way more like performing surgery. It's this incredibly meticulous ritual where every single step matters. The whole procedure for mounting the rail is, well, it's a masterclass in being methodical. First, the surface it's going on has to be surgically clean. No dust, no bumps, nothing. Then, you only temporarily fasten the rail down. Then comes the really crucial step. You use these little set screws along the side to push the rail perfectly flat against a reference edge. Only after all that do you fully tighten the main bolts. And guess what? Even that has a rule. You have to tighten them in a very specific sequence, from the center outwards, to stop any tiny bit of warping.
And here you can see that critical step in action. See those little set screws? They're not for holding the rail down. They're actually pushing it sideways. Their whole job is to make sure the rail is perfectly, absolutely straight along its entire length before it gets locked into place. And that's the key here. The real straightness comes from that sideways push, not from cranking down the main bolts on top.
Okay, but what if you're using two rails? How in the world do you get them perfectly parallel? I mean, you could spend hours and hours with all sorts of complex measuring tools, or you could just use this brilliantly simple system that's built right into the product. It's called the master/subsidiary system. Here's how it works. When you buy a pair, one is the master rail. Its reference surface is machined to an even higher level of precision. So the rule is dead simple. You install the master rail first. You get that one perfect. Then you install the subsidiary rail, and all you have to do is align it to the master. The master sets the perfect line, and the subsidiary just follows its lead. I mean, how elegant is that? It's a beautiful solution to a really complex problem. And of course, the rules don't stop there. When you go to mount the blocks onto the table, the part that's actually going to ride on the rails, you can't just wrench down the bolts in any old order. No, you have to follow a specific diagonal sequence. It's just like tightening the lug nuts on a car wheel, right? You do it to make sure the pressure is totally even across the block, which prevents any tiny warping that could mess up the accuracy. All right, so you followed every single rule to the letter. It's installed perfectly. You can finally kick back and relax, right? Wrong, not even close. Now a whole lifetime of care begins. And you guessed it, it's governed by another set of rules.
For these things, lubrication is everything. It's the key to long-term performance. And the first rule of lubrication is before you even think about adding new grease, you have to wipe that rail completely clean. And it all comes back to that same old enemy, contamination. Any bit of dirt left on that rail will get dragged right inside by the block seals, and that's how you cause damage. Then, step 2, you apply a really thin film of grease right onto the rail itself. And what's interesting is, the manual says this isn't even for lubricating the balls inside. Nope. This layer is specifically to protect the rubber dust seals on the block, to make sure they slide smoothly and don't get worn down.
And then finally, step 3. You inject grease through this little nipple right into the block's internal guts. This forces fresh lubricant into all those little pathways where the tiny balls are doing their thing, keeping the motion perfectly smooth. So how often do you have to go through this whole routine? The manual recommends about every 100 kilometers of travel. Just think about that for a second. This part's maintenance schedule isn't based on time, it's based on distance. Just like a car, it's this really tangible reminder that this thing is constantly moving, constantly doing real hard work. So why? Why go through all this incredible painstaking effort for precision? Why do all these hidden rules matter so much? Well, it's because these guides are used in machines where failure is simply not an option. We're talking about things like medical scanners, components for aviation and space, even nuclear power systems. In applications like these, one tiny error in motion can have absolutely massive consequences. So this isn't just about making a machine run smoothly, it's about guaranteeing safety and reliability in some of our most critical technologies. So it turns out that simple-looking chunk of steel is governed by this deep and complex set of hidden rules. It really makes you wonder, doesn't it? Our whole modern world is absolutely built on this kind of invisible precision. So maybe the next time you see any piece of technology, big or small, just ask yourself, what are the hidden rules that actually make that thing work? What other simple objects all around you have a surprisingly complex story to tell?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.